Okay, guys, so today I want to begin with the fact that interest rates have an inverse relationship with bond prices. Interest rates have an inverse relationship with bond prices, meaning that if interest rates go up, bond prices will go down. Why is that? To show this, let us consider the simplest kind of bond that we can come up with, which is a zero coupon bond. Consider a zero coupon bond, meaning there are no coupons, just a redemption at the end. So, let's say that the face amount of this bond is $1,000. And let's say that the redemption is also $1,000. So this is a par bond. Redemption at time, let's say at time 1. Make it nice and easy. 1,000. And F equals 1,000. Price I don't know yet, right? P for price, I don't know what that present value is. And let's find the rate of return right now. So what is the rate, the yield rate, or the rate of return for this? Let's say that initially the price is given to be $950. So I can buy a $950 bond, which will pay me $1,000 at the end of 1 year. And I'm looking for the rate of return. Can you help me? What do you think?
Negative 950 plus 1,000, 1 plus I minus 1.
So can I say 950 equals, go again?
So 1,000, 1 plus I to the minus 1.
1,000, 1 plus I to the minus 1. Where is he getting this, guys? Do you know? Where is this coming from? So there are many ways to look at it. The first way I can look at it is my price equation. Yeah?
Is 1,000 times VT.
1,000 times V to the 1?
VT. This means that V is equal to 1 plus I minus 1.
Right. So I have two ways to look at the situation. I could say that it is equal to my price formula, which is just P equals FRA angle NI, which is all 0 because FR is 0 because there are no coupons at all. So FRA angle NI, N is 1 here. This is 0 because there are no coupons. Plus C V to the N. So this is my CV to the N right now. 1,000 V to the 1. Okay, so we solved this equation. In other words, I could have done this too, right? 950 times 1 plus I equals 1,000. Solve for I. Does this make sense? Just back to basic principles, right? From week 1. You see it, right? What is I? Solve for I. Pull out your calculator and solve for I. What do you get? What do you get, Brandon?
I'm not done yet. .052632.
Okay, so solve for I equals 0.0526. it's a 5% return, right? Now, I'm gonna raise interest rates. Now, interest rates go up in the market. Interest rates rise. Oops. What do you think is going to happen? That means that outside, people can get 10% now. This bond is paying 5%. Right? So let's say interest rates rise to 10% outside, meaning in the market. So what will happen here to my bond? Who's going to want to buy a bond for 5% that pays 5%, that yields 5%, when you can get 10% outside? So what do you think happens to the price of this bond? Yeah, the demand will decrease, and therefore the price will decrease. So let's say here, who wants a 5.26% bond, meaning yield bond, when they can get 10% in the marketplace? So to attract demand, the price will have to drop to yield 10%. So now the next question is, what's the price? What will the price drop to? Same equation that Brandon was talking about before, right? Price, new price, will have to be C Vj to the n, which is C over 1 plus I to the n, is equal to 1,000, 1 plus 0.10 this time to the 1 power, which is now 909.09. The price used to be 950. The new price is going to be 910, 909, right? They're going to have to adjust the price because nobody is going to pay 950 for a 5% bond anymore, because they could just go to Apple Savings Bank and get 10%. Follow me? Okay, just the opposite happens if interest rates fall. Let's go back up. If interest rates fall, this bond is now highly desirable. And its price is driven up. The same way that the price was driven down in the other scenario. You get it, right? All of a sudden interest rates are 2%. Everybody wants this bond now because this bond is paying 5%. Follow me? So I've taken the simplest scenario possible. I could have taken something with coupons and stuff. But why? You can see it, it's crystal clear without the coupons. Add the coupons, the same thing happens, of course. Right? If interest rates rise to 10%, nobody wants 5% coupons. It's like a joke, right? Okay. Continue with the lecture notes then. So we are now on page 6. we're going to talk about the bond amortization schedule. So just like the loan amortization schedule, there is now a bond amortization schedule. Very similar, but there are some fine details that you have to pay attention to. I'll just go to my page 6 here. Okay. And as I go along, I'm going to make a comparison between the loan amortization which by now we should be familiar with, and if not, you will be reminded as I go along. And here's the bond amortization. Because as we said before, the bond is just the investor, the guy who's buying the bond, now loaning the government the money, or IBM. Let's say the bond is issued by IBM. It's the investor who is buying this bond who is now loaning IBM the money, right? So a similar situation should occur here for bonds as it did in loans. In the case of the loan, it was the TFCU loaning you money. Now you're loaning the company money, the government money, whoever is issuing the bond. Okay, so first thing, B naught here used to be the loan amount. B naught, by B naught I mean OLB, 0, right? OLB at time 0 was the loan, L. What do you think B0 would be now for the bond? What do you think? What do you owe at time 0? What does the company owe you at time 0 if you just bought this bond? Price. Exactly right. B0 is equal to the price. You just finished paying $950 for this bond. This is the value of the debt, $950, let's say. I'm just making up some number. So B naught is equal to price. How about here? BN, in the case of the loan, was what? What happened when you came all the way down to the bottom? OLBN was what?
Is the last time.
N is the last time. You have a loan for 30 years. You're making the last payment. What is OLBN? 0, right? Okay. Here comes the difference. Okay, and this has to be crystal clear. BN. This is called the book value, by the way. The OLBs are called the book values of this bond, meaning what is the remainder of the debt on this bond. Talk to me. BN. What do you think it is?
The redemption amount?
Yeah, it is C. BN is equal to C. Do you see the difference right here? So what are you amortizing? On the bond, what are you amortizing? You are only amortizing the difference between the price and the redemption. Whereas here, you are amortizing the entire loan, L minus 0, right? Your principal paid here has to sum up to L, because L is the amount of the loan, and the difference in the OLB between here and here used to be L. So when you add up all those principal payments, P of T, they have to add up to L. Not the case now. That's the whole difference. If you don't get that, if somebody doesn't drive that point home, you're never going to understand the amortization schedule. So here you are trying to amortize price minus C, which of course we call either premium or discount, which is absolute P minus C.